In 1950, a British mathematician sat down and asked one of the strangest questions anyone had ever put to paper. Not, can we build a faster calculator? Not, can a machine do algebra? He asked, can a machine think? And here's what makes that question so remarkable. 75 years later, with ChatGPT on every phone and AI reshaping every industry on the planet, we still don't have a clean answer. By the end of this video, you'll understand why that question was asked, what it actually means, and why the answer matters more right now than it ever has before.
Plain Machine, AI in plain English. This series traces the full story, from the first question of whether a machine could ever think, all the way to the systems on your laptop right now. It's a better story than most people realize. Let's get into it.
Let's start with something that sounds simple, but turns out to be genuinely difficult. What does it mean to think? If you ask most people, they'll say something like, thinking is what happens inside your head. Fair enough. But that answer creates an immediate problem. We can't see inside anyone's head. We can't verify that another person is actually thinking, as opposed to just responding to stimuli in a very sophisticated way. We assume other people think because they behave like we do. They answer questions, they solve problems, they tell us what they're feeling. Now here's where it gets interesting. In 1950, Alan Turing, the British mathematician I mentioned at the start, published a paper called Computing Machinery and Intelligence. And in it, he made a move that was either brilliantly pragmatic or philosophically evasive, depending on who you ask. He said, let's not ask whether a machine can think. That question is too hard. Instead, let's ask whether a machine can behave as if it thinks. Can it fool a human into believing it's human? He called this the imitation game. Today, we call it the Turing test. Here's how it works. You're sitting at a computer. You can type messages, but you can't see who or what is on the other side. On one end might be a human. On the other end might be a machine. Your job is to ask questions and figure out which is which. If the machine can consistently fool you, if it can hold a conversation well enough that you genuinely can't tell the difference, Turing argued that we have no meaningful basis to say it isn't thinking. Notice what he did there. He didn't define thinking. He sidestepped the philosophical quicksand entirely and replaced it with a practical test. And that move, replacing an unanswerable question with a testable one, turns out to be the founding logic of the entire field of artificial intelligence. This is the core insight of this video, so let it land for a second. The field of AI was not built on a definition. It was built on a test.
So now we understand the Turing test as a concept. But let's go a level deeper, because the real story of AI starts with the question Turing was actually trying to answer underneath that test. He wasn't just building a party trick. He was asking something profound about the nature of intelligence itself. At the time, 1950, the dominant belief was that human intelligence was fundamentally different from anything a machine could do. Intelligence was seen as a spark, something biological, something that couldn't be reduced to calculation. Turing pushed back. He said, look at what a human actually does when they think. They take in information. They process it against what they already know. They produce an output. That's a process. And if it's a process, it can in principle be described. And if it can be described, it can in principle be replicated. This is called the computational theory of mind, the idea that thinking is fundamentally information processing, and that any physical system capable of the right kind of information processing might, in principle, think. This was the intellectual foundation, not code, not circuits, not training data, a philosophical argument about what thinking is.
Now, here's why this matters so much, and why this isn't just ancient history.
Every single AI system you interact with today is built on descendants of this foundational idea. When ChatGPT generates a response to your question, it is doing exactly what Turing described, taking in information, processing it against an enormous body of learned patterns, producing an output. It does not have opinions, it does not have experiences, but it processes information in a way that produces outputs which are, in many cases, indistinguishable from what a knowledgeable human would write. Which means, by Turing's own test, we're already there. Modern large language models pass the Turing test in most practical scenarios, and yet we're still arguing about whether they think. Why? Because the Turing test measures output. It tells us nothing about what's happening internally. A machine that gives brilliant answers might be doing something completely different from what we do when we think, even if the results look identical from the outside. This gap between what AI does and what it is the central tension of the entire field, and it's why the question Turing asked in 1950 has only gotten more relevant, not less.
So, what are the limits of Turing's framework? The most famous critique comes from a philosopher named John Searle. In 1980, he proposed what's called the Chinese room argument. Here's the thought experiment. Imagine you're locked in a room. You don't speak Chinese, but you have a rule book that tells you exactly how to respond to any Chinese symbol with the correct Chinese symbol in return. Someone slides questions in Chinese under the door. You consult your rulebook and slide back correct answers. From outside, it looks like you speak Chinese, but you don't understand a single word. Searle's argument, a computer program is like the person in that room. It manipulates symbols according to rules. It produces correct outputs, but it doesn't understand anything. It has what Searle called syntax, the rules, but not semantics, the meaning. Turing's defenders say, so what? If the outputs are indistinguishable, the distinction is meaningless. Searle's critics say the distinction is everything. This debate is unresolved. It is being actively argued right now by serious people with the most capable AI systems in history as the evidence. The point isn't to resolve it here. The point is this. The questions that launched artificial intelligence as a field are not academic relics. They are alive, urgent, and sitting inside every product decision, every policy debate, and every conversation about what AI systems should and shouldn't be allowed to do.
Now, here's what this actually means if you work with AI tools. Because this isn't just philosophy. This history shapes how you should think about the AI systems you use every day. First, understanding that AI was built on a behavioral test, not a definition of intelligence, explains why AI is so good at some things and completely lost at others. Large language models were trained to produce outputs that look like what a human would write. They are extraordinarily good at that. But they were not trained to understand. They were not trained to reason from first principles. They were trained to predict what word comes next, what response fits this pattern. This is why they hallucinate. This is why they confidently give you wrong answers. Not because they're broken, because they're doing exactly what they were designed to do, producing plausible-looking outputs. Whether those outputs are true is a separate question they weren't built to answer. If you're using AI tools in your work, and most of you are or soon will be, this is the single most important mental model to carry. AI output is a pattern match, not a truth claim. Treat it accordingly. Verify what matters. Leverage what it's brilliant at.
Second, if you're in any kind of management or leadership role and you're making decisions about how to use AI in your organization, the Turing test framing is genuinely useful. Ask, does this task require understanding, or does it just require output that looks like understanding? Writing a first draft, output. Evaluating whether that draft is strategically sound, understanding. Summarizing a document, output. Deciding what to do with that summary, understanding. And tasks AI is brilliant at are the tasks that the Turing test was designed to evaluate. Everything else still requires you.
And third, and I want to say this directly, understanding the history of these questions makes you a better user of AI.
not because it changes how the tools work, but because it changes how you think about them. The people who will use AI most effectively over the next decade are not the ones who use it most. They're the ones who understand what it is, what it isn't, and when the distinction matters.
So, can machines think? Here's where we've landed. Turing said, ask the wrong question and you'll argue forever. Ask the right question, can it behave as if it thinks? And suddenly you can make progress. That move from the unanswerable to the testable is what made artificial intelligence possible as a science. Without it, we'd still be arguing philosophy. Because of it, we spent the next 75 years actually building things. The machines we've built are extraordinary. They pass the test Turing designed. They produce outputs that are, in many domains, indistinguishable from human intelligence. But the original question is still open, and it's getting more important, not less, because the systems are getting more capable. Understanding that question, where it came from, what it means, why it's hard, is the foundation of everything else we're going to cover in this series.
In the next video, we're going further back than 1950, all the way back to the mathematicians and logicians who spent centuries trying to turn thought into a formal system. Because Turing didn't arrive at his question from nowhere, he was standing on 200 years of accumulated thinking about the nature of mind. That's video 2 in this series, and it's a stranger and better story than you might expect. If this video was useful, subscribe. We publish one video per week in this series, and each one builds directly on the last. You don't have to watch them in order, but if you do, the whole picture comes together in a way that I think you'll find genuinely satisfying. I've also put together a one-page AI glossary, 30 essential terms defined in plain English, which you can download free from the link in the description. It's a good companion to this series. This is Plain Machine. Thanks for watching.